Okay, my voice is audible to all of you.
Yes, sir.
What about screen is visible to all of you?
Yes, sir.
Yes, thank you. Okay, once again, welcome to all. Today, I'm going to discuss one more concept is called as theories of failures. Okay, so in gate examination, they will ask 1 mark. That is depends on the question paper pattern. Maybe they will ask 1 mark, or sometimes they will ask 2 marks. Okay, so here in our design concept, the theories of failures are very important. As a mechanical engineer, before design any component, where that system is going to failure, under which load the entire component or entire construction or entire system which will be failure. That is the main target or main aim of the every design engineer. Okay, so here the theories of failures are mainly used to determine the component where which can be subjected to different types of stresses based on the various type of loads. Okay, I think all of you know what type of loads are generally you observe in our design of component. Anyone, you please tell me the answer. Kindly give me the answer. So, what are the different types of loads generally you observe as a mechanical engineer? Please. Yes, please. What type of loads you generally observe in our design of components? Already you completed mechanics of solids and engineer mechanics, strength of materials. Yes. So in our MOS also you clearly observe in that mechanics of materials also you clearly observe what are the different types of loads generally which
Shear,
can.
shear
Yes,
bending.
yes, good, good. So here generally 4 to 5 different types of loads you observe, which can be to get a deformation or deflection or bending or stresses. Okay, the first load is called as a tensile load. Okay, tensile load, we're called as a sigma, what you called as a WT, that is tensile load. And one more load is called as a compressive load. Compressive load. And third one, shear load. Okay, shear load. Okay, in springs, which is going to happen to the bending load also, that is a WB, bending load. Okay, and one more torsional load. Torsional shear load, or we can call it as a torsional load. Clear? So these different types of loads generally you observe in our design of a mission component. Yes or no? Yes or no?
Yes, sir.
Yes. Okay. So with respect to the tensile load, what type of stress you observe? Tensile stress. Yes.
Yes,
Clear.
sir.
With respect to the compressive load, which can be developed a compressive stress. Re- Respect to the shear load, shear stress, that is tau. With respect to the bending load, what type of stress you observe? Bending stress, that is sigma B. Clear? If it is a torsional shear load, what type of stress you are going to observe? It is torsional shear, tau S. That means the stress is purely depends on the type of load which can be applied in a given component. It is right or wrong? It is right or wrong? Say yes or no. It is right or wrong?
Yes, sir.
So here, what is the stress formula? Stress is equal to what is the formula? Load by area. Yes, load by area. Okay. If you're having a more amount of stress, what is the area? Less amount of the area. Okay, now more amount of the load. If you keep on increasing the load, what happens? The stress is going to increase. Okay, so why I am going to saying this all the things is the theories of failure is depends on the type of stress and the type of load which can be subjected. But here, combined stress. What is a combined stress? Anyone can give me the answer? What is a combined stress? What is combined stress? So here, for example, I am going to take one chassis here. It is one chassis. Okay. Before design a chassis, before design a chassis, as a design engineer, first you check the dimensions of the chassis. That is length, breadth, and what you call it as what is the chamfer angle. Okay, na? What is the guide base and what type of material we are going to use. We are going to check whether the the loads which can be resist or not. Combined stress means two different types of stresses which can be involved at a particular time in a given component is called as a combined stress. That is, the theories of failures are mainly evaluated based on the combined stress which will be respected to the type of various loads acting on the component. As a design engineer, before design a component, you have to check it whether the system is working or not as per the given dimension, as per the given stresses, as per the given loading conditions. Yes, I understand what I am saying. I understand or not?
Yes, sir. Understand.
Okay, right. So, what are the examples? For example, in IC engine, you have designed a crankshaft or camshaft or any what you call it as a piston or cylinder. What are you going to do? What type of material to be used to avoid the failures? Okay, na? What type of stresses which will involve whenever the piston is moving from the TDC to BDC? Clear. So any system like shafts or screw jack or any bolt or any gaskets, flywheel, gears, and what you call it as gear assembly, steering mechanism, a small washer. So each and every mechanical component, first you check the theories of failures whether it can be working or not uh, uh, in a given loading conditions. That is the main motto and the main use of the theories of failures. For gate examination purpose, you are talking about theories of failures. They will generally ask the problem. Okay, na? So in our theories of failures, generally it can be classified into 5 types. Okay, na? Before that one, I think all of you know what is a two-dimensional system and three-dimensional system. Anyone in the class? What is 2D and 3D? What is 2D and 3D?
టూడీ అంటే ప్లెయిన్ గా చూస్తాం సార్.
Okay.
3D అంటే అన్ని డైరెక్షన్ లో అన్ని డైమెన్షన్ లో చెక్ చేస్తాం సార్.
Okay. So in a two-dimensional system, for example, it is y-axis. This one is x-axis. Clear? It is x-axis, and this one is y-axis. Okay. So in x-axis, whatever the stresses which will develop, that is called as stress in x-axis. If strain is developed, it is sigma x. If it is shear stress, that is tau. Yes or no? If it is y-axis, the stress which will develop, that is sigma y. Sigma y. If it is strain, ey. Ey. If it is shear, that is tau y. It is tau x. Clear? For example, here one body is there. One body is there. If I am going to apply a compressive load along the x-axis, that means like this. Clear? This one is called as a sigma x. Sigma x. Here also sigma x. When you develop a stress along the y-axis, that is called as sigma y. sigma y. Yes, I understand.
Yes, sir.
Yes. So for example, in our two-dimensional system, we are going to calculate what is the principal stress, what is the principal strain. Okay, now what is the principal stress here? That is called as sigma T1 is the maximum principal stress. Clear? Sigma T2 is the minimum principal stress. Sir, how can we say it is maximum or minimum? That I will tell you. Okay, next. In 3D concept, we are going to having a three coordinate system that is called as x-axis and y-axis and z. It is y-axis, sorry, it is x-axis, this one is y-axis and this one is z-axis. Here I am going to take one body here. I am going to consider one body here. If it is along the x-axis, this one is called as sigma x. Along the y-axis, this one is called as a sigma y. But what about sigma z? That is called as a inclined plane. That is called as a oblique plane. In oblique plane, always we're going to take a shear stress value. The main difference is in two-dimensional system, we're going to evaluate the system in x plane and y plane. But in three-dimensional system, we are going to consider two planes. One is principal stress, other one is called as a principal shear stress. Okay, right. So in this in sigma t1 always were called as a maximum principal stress. So whenever if you're going to take both x and y axes, in this both the axes, always the sigma axis is called as a sigma t1 value, that is maximum principal that is called as more amount of the deformation or elongation we have to observe in the given plane. That plane is called as a maximum principal stress plane. Or if the maximum amount of the strain or shear will be observed, that is called as a maximum principal strain. Clear? So and also in y-axis we have to observe only for the less deformation or elongation. Here we are called as a sigma t2 value. So in that purpose, the sigma t1 always it is a positive side. It is positive side. So in sigma t2 always it is a negative sign. If it is negative, it is a tensile stress. If it is positive, it is a what do you call it as a compressive stress. Clear? Okay, but in these two values we are going to calculate what is the principal stress sigma t1 and what is the principal strain sorry sigma 1 in x plane and sigma 2 in y plane. Sigma 1 and sigma 2 is called as a only principal stress in x axis and y axis. Sigma t1 and t2 is called as a maximum principal stress. Clear? Maximum principal stress. Please remember. In this basic information, I am going to classify the 5 different types of failures. First one is called as a maximum principal stress theory, maximum principal strain theory. Third one, maximum shear stress theory, and maximum strain energy theory, and maximum distortion energy theory. These 5 are very important for your gate exam. They will ask one problem in these 5 theories. Please remember and please try to understand very clearly. It is somewhat very tough. Okay, see, so the maximum principal stress is also called as Rankine's theory. Sometime in our gate examination they will give the match the following. Okay, now maximum principal stress theory is also called as Rankine's theory. Maximum principal strain theory is also called as Saint-Venant's theory. Okay, maximum shear stress theory is also called as Guest and Tresca theory. Okay, maximum or strain energy theory is also called as Hike's theory. Maximum distortion energy theory is also called as Von Mises and Young's theory. These 5 names are scientists names. They will develop the theory. So just you remember one more name for each and every theory. First I will discuss maximum principal stress theory, maximum principal strain theory. Okay, see what is the first maximum principal stress theory. Okay, so here before that one, I think all of you know what is the elastic limit and what is the plastic limit. Anyone? What is elastic limit? What is plastic limit? Babu.
సార్ ఎలాస్టిక్ అంటే సాగుతుంది సార్.
Okay. What is plastic limit? చెప్పండి పర్లేదు. If you're giving wrong answer, no problem. But I want interaction. Clear? Please tell me. What is elastic limit? What is plastic limit? Okay. According to stress strain theory, what is called? This one is proportional limit, lower yield point, upper yield point. Okay, na lower yield point, upper yield point, ultimate stress, and last one is break even point. Clear? Yes, I'm right. I'm right or wrong? Yes. So here elastic means what? When you apply the load on a body, it will be elongation takes place. After removing the load, it regains the original condition. Yes or no? Clear? In this elastic limit, always you observe there is no deformation or no failure will be occur. In this elastic limit, we are not supposed to use any theories of failures. Please remember in our mind. Why? Because of in the elastic body, always try to elongate. Whenever if you're going to apply a load, after removing load, what happens? It regains original position. What is the example? You give me one example for elastic limit. For example, spring is there. When you apply the load, what happened? The spring is going to compress it. After removing load, the spring is going to elongation. Yes or no? So in the spring, if you observe any deformation, if you observe any break-even point,
No, sir.
no. For example, steel material, you observe any failure after applying a heat. What happened? It is going to draw some small wires. Yes or no?
Yes, sir.
That why? Because of in the elastic limit, we should not observe any failure. That's why for elastic materials, for what you call it as ductile material, we are not have to focus on theories of failures. Okay, na only the theories of failures will be applied only for plastic limit. What is the plastic limit? If you're going to observe the load, it will elongate. After removing load, it should not regain its original position. Should not regain. For example, glass metal is there. If you drop the one teacup, what happened?
బ్రేక్ అవుతుంది సార్.
So, what is the indication? It is nothing but brittle material. Yes or no? Right? That is the plastic. The theories of failures will be applicable for plastic material, especially for brittle components. Clear? That is the main motto. That's why we clearly say that the theories of failures will applied only for brittle material. In our MOS lab also, you clearly observe universal testing machine is there na. When you apply the load, what happens? The rod is try to elongate after the maximum loading condition. Up to the maximum loading condition, what happens? It will reach the proportional limit, lower yield point, upper yield point. Okay, na? But in this maximum principle stress theory said that it is defined as the stress will reaches the maximum yield point value of material under the simple tension test. What is the yield point? What is the yield point?
బ్రేకింగ్ పాయింట్ సార్.
Breaking point. Okay, so after crossing the elastic limit, what happened? What happened after crossing the elastic limit? What
బ్రేక్
happened?
అవుతుంది సార్.
It will try to break the specimen. So whenever the given component will lose the strength and lose the strength, then what happened? The yielding or the yield point will occur. Under the yield point, what happened? It is going to lose the stress. That is, what is the maximum load which can be resisted by the specimen? That point is called as a yield point. After yield pointing, what happened? Breaking is going to occur. That's why the maximum principle stress theory says that the yielding point occur. The yielding point occur or it will be reaches the maximum yield point value of the material under a simple tension test that is called as a maximum principal stress theory, is also called as a Rankine theory. This Rankine's theory is mainly applicable for only only brittle material. Brittle material. Clear? Okay. So, and one more thing is called as here. One more. Okay, okay, right? Okay.
Yes,
So,
sir.
so in this, what you call as the maximum principal stress theory is applicable for a brittle material, and one more is called as in this in this system we're going to explain how to calculate the maximum principal stress theory. See here. Okay. So in this theory we are going to apply both biaxial and triaxial. What is biaxial and triaxial? Anyone? What is biaxial and what is triaxial? What is biaxial and what is triaxial? Please, anyone? What is triaxial? What is
యాక్సిస్ అంటే టూ డైమెన్షన్స్ కలిపి ఉంటాయి సార్.
Okay, good.
ట్రయాక్సిల్ అంటే త్రీ ఆర్ మోర్, త్రీ ఉంటాయి అంతే సార్.
That is simply called as biaxial means two-dimensional system. Triaxial means three-coordinate system. If you are going to take a biaxial plane, sigma 1 is equal to, that is principal stress is equal to sigma T1. Okay, sigma T2 is equal to what called as sigma 2 is equal to sigma T2, that is equal to 0. That is equal to 0. Why it is equal to 0? In our theories of failures, we should not consider y-axis deformation. Why? Because of in y-axis, if you're going to consider the plane, what happened? The simply it is going to negative 0. That is, in y-axis, we are not have to observe any deformation or elongation. We observe only for along the axis the stress and strain. That way, the sigma 2 is equal to always 0. Please remember, if it is a triaxial plane, sigma 1 is equal to sigma T1. Okay, right? Sigma 2 is equal to sigma T2. Good. What about sigma 3 is equal to 0? Why? Because of in 3D components, we're having a length, width, and thickness. We observe the deformation only width and thickness. We should not observe any length point of view. Right or wrong? Right or
ఎస్
wrong?
సార్.
Yes, that's why in our theories of failures, we are going to calculate what is the maximum principal stress in x-axis and the maximum principal strain in y-axis if it is a 3D system or if it is 2D system. That's why the maximum principal stress theory is defined as if you are going to observe the maximum amount of the load which can be reach the yield point value under the simple tension test. The theory is called as a maximum principal stress theory, is also called as Rankine's theory. Clear? This theory is mainly applicable for only brittle material. Right, good. Next, how to calculate? Okay, na? So before that one, the sigma T1, that is maximum principal stress, sigma T1, if you're going to calculate the brittle material, that formula is ultimate stress by factor of safety. Indeed, sigma T1 is equal to sigma U, that is ultimate stress by factor of safety. What is ultimate stress? Anyone? 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 What is ultimate stress? As a mechanical engineer, you clearly know that what is by ultimate stress, yield point stress, break even point, factor of safety. Before that base, without this basic, it is very difficult to understand the concept. Okay, but I am asking only simple basics. What is meant by ultimate stress? Please.
Metal withstand.
Okay, good. Withstand. What is the maximum amount of load can be withstanded? Respect to stress is called as a ultimate stress. But what is yield point stress? Almost both are similar, na? Or different? Why it is ultimate stress and why it is yield point stress? So up to ultimate stress, that body will be coming under elastic limit. Yes or no? Yes or no? Ultimate means what is the ultimate? The ultimate means what? What is the maximum amount of load it can be resisted? That is called as ultimate point. It is called elastic limit. Once the body will be converted or transferred from the ultimate stress to the yield point stress, it is called as a plastic limit. Clear? In yield point stress, the stress is zero, but the strain is keep on increasing. It will reach the break even point. Clear? Okay, ultimate means what is the maximum amount of load bearing capacity under the specimen is called as the ultimate stress. Yield point means what is yield point? Under the stress, you clearly observe the deformation or breaking or bending or shear. That is called as a yield point. The uh, ultimate stress, it is a elastic condition. Under the yield point stress, it is a plastic condition. Please remember. So when you calculate the sigma T1, here sigma T2 is equal to 0, and I told, okay, but sigma T1 for ductile material is sigma U by factor of safety. It is for only brittle material. If it is ductile material, sigma T1 is equal to sigma YT by factor of safety. Why it is sigma U and sigma YT is there? Anyone you observe? You observe? Why it is brittle material for sigma U? Why it is ductile material for sigma YT? Anyone? Please try to understand, ma. Try to interact with the faculty. Then only you clearly understand. Why I'm going to explain each and everything is very clear. Why? Because of this is very important while you solve the problems. Okay. Why here in brittle material you take a sigma U value? In ductile material, why you take a sigma YT value? Please.
Young's modulus.
No. No. Wrong answer. For example, if I am going to drop one teacup, what happened? Before breaking, it will be give any signal. Babu, if I am going to drop a teacup, that is called as a what do you call it as that? What do you call it as? What type of material we're going to use? That one is only for this one. That is a concrete note, ceramics note. For small in our home, while you drop the teacup, what happened? It will be give the any signal before a breaking. Babu.
No, sir.
No. Okay, na. If you're not giving any signal, what type of material it is? For example, one glass is there, one glass material is there. If you drop the glass material, if you get it will be give the signal or not give the signal before breaking. Babu, signal istunda signal ivada?
ఎవరు సార్?
Without giving any signal, it is called as a brittle material. If you take any cast iron rod, before break it, it will give the signal or not? In our UTM mission, if you are taking a UTM mission, when the rod is keep on elongation, what happened? The small neck is going to formation. Yes or no?
Yes, sir.
Yes or no? So that material is called as a ductile material. That is, in ultimate means, the brittle material, we are not supposed to get to estimate the what is the amount of load it can withstand. But in yield point stress, you clearly understand how to up to what load it can be resist the load without any deformation. Clear? So there's the main difference between the brittle material and ductile material. That's why for brittle material, sigma T1 is equal to sigma U by factor of safety. Sigma T1 is equal to sigma YT by factor of safety is called as a ductile material. Clear? Okay, good, right? Okay, so for example, one small problem is there. You should note down, all of you. You should note down, all of you. Please note down. For example, one bolt is there. Okay, na? One bolt is there here. Okay, one bolt is there. The bolt maximum ultimate load sigma U is equal to, the ultimate stress of the bolt is equal to 320 kilonewton. 320 kilonewton. Okay, 320 kilonewton. Okay, what is the factor of safety? What is factor of safety? What is factor of safety? What is factor of safety? Hello, what is factor of safety, ma? Design stress by working stress. It is a ratio of design stress by working stress. Okay, so in our problem, they will give the factor of safety value, or they will give the design stress is 240 megapascal. Okay, working stress is 180 megapascal. Okay, you just calculate what is the maximum principal stress for ductile material, for brittle material. Okay, so in that problem, they will indirectly ask that you have to calculate the first factor of safety. The factor of safety, sometimes they will give the direct value, or if you not give the direct value, the factor of safety is equal to design stress by working stress, or ultimate stress by working stress. Please remember. Okay, all right. So they will give the design stress and working stress. Based on these two values, first you calculate the factor of safety value. Again, go for sigma T1 is equal to, what is the formula here? Sigma U, ultimate stress by factor of safety. Just you substitute the values and you're going to calculate what is the sigma T1 value. Or sometime sigma U is equal to, ultimate stress is equal to 0.5 times of sigma Y, or sigma YT for steel material. If steel material, the ultimate stress is 0.5 sigma Y. If it is what you call it as ductile material, the sigma U value is 0.55 times of sigma Y. Please remember. If it is brittle material, the sigma U is equal to 0.44 times of sigma Y. These three values are very important if they will not give any data in our given problem. Okay, so the loops are very important. So in gate examination, they will not give any direct data. Based on the given problem, first you understand what are the ways to solve the problem. Clear? One thing is, if you are going to calculate the factor of safety, based on this factor of safety, you calculate a sigma T1. Or if you are not giving any design stress and working stress, how to calculate the sigma T1? Based on the type of material. If they will give brittle material, sigma U is equal to 0.44 sigma Y. They will give the yield point stress value. So గుర్తుపెట్టుకోండి, sigma u value అనేది in terms of sigma y లో ఉన్నప్పుడు they will give yield point stress, they will not give sigma u value. For example, sigma y is equal to 420 megapascal. Okay, first you calculate the ultimate stress value. How are you going to calculate for the brittle material? Sigma u is equal to, what is the formula? 0.44 into sigma y. Yes or no? Yes or no?
Yes, sir.
Yes. Based on this formula, first you calculate the sigma u value. After getting sigma u value, just to substitute the given equation, you have to calculate the sigma t1 value. It is very important bit. The problem in gate exam 2016, they will ask the problem is the load on the bolt consists of axial pull of 20 kilonewton together. The transfer shear load is 10 kilonewton. How to calculate the maximum principal stress? They will give the ultimate stress value, factor of safety value, and how to calculate this sigma t1 value. Simple question. Okay na? That is about maximum principal stress theory. Okay na? So in maximum principal stress theory, always you calculate the sigma t1 value for ductile as well as the brittle material. This can be applied for only brittle material. Okay na? So I understand the concept of this first theory of failure.
Yes, sir.
Yes. So one more very important point is the maximum principal stress theory will be applied for rectangular components. Note down. The rectangular component, what type of theory is applicable? Maximum principal stress theory is also called as Rankine's theory. Okay, that is a concept of first theory of failure. Okay, I will go for a second theory of failure. Second theory of failure, maximum shear stress theory is also called as a guest theory. Maximum shear stress theory is also called as a guest theory. What is shear stress? Anyone? What is shear stress? What is shear stress? Anyone? What is shear stress? Please. What is shear stress? What is shear stress, ma? Huh?
P equal to F by A, sir.
No, I'm not asking formula. I'm asking what is a clear definition of shear stress. Here it is my specimen. Okay, na? It is along the x-axis, along the y-axis. Along the x-axis, it is along the y-axis. Okay, it is my body. Along the x-axis, if deformation occur, the strain is called as linear strain or longitudinal strain. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
If the stress is if the strain is occur along the y-axis, that is called as lateral strain. Lateral strain. Whatever the stress or strain will occur along the x-axis, that is called as a longitudinal stress, longitudinal strain. Whatever the stress and strain will occur along the y-axis, that is called as a lateral strain, lateral stress. It is the ratio of longitudinal stress by lateral stress is called as Poisson's ratio. Right? I am right? I am right or wrong? Babu, I am right or wrong? 1 by m is equal to Poisson ratio. It is a ratio of longitudinal stress to the lateral stress. If whatever the load, whatever the stress will occur along the y-axis, or the load is going to applied, which is perpendicular plane to the specimen. What happened? The specimen is going to shear. That stress is called as a shear stress. Right or wrong? Right or wrong?
Yes, sir.
In shear stress, the specimen is completely breaking. Okay na? So in compression and tensile, the specimen will not break. In shear stress and shear strain condition, the given specimen is completely failure when you applied the load which is perpendicular to the plane. But in this theory, the failure will occur the maximum yield point. Why it is yield point? In yield point only we clearly observe the we clearly observe the breaking na. Up to elastic, up to ultimate point, we should not observe any break even point. After reaching the elastic, ultimate point, under the yield point only, we clearly observe the shear point or not. Yes, Babu, clear?
Yes, sir. Yes, sir.
That means according to according to this theory, the shear stress or the shear failure will occur maximum yield point of a specimen under a simple tension test. That theory is called as a maximum shear stress theory. Here we are talking about only shear stress. In the previous failure, we are talking about only principal stress. In principal strain theory, we are talking about only principal strain. So remember, okay, in this theory is mainly applicable for ductile material. Why? Because of the shear failure, we should not apply it for brittle material. We clearly applied only for the ductile material. That means the load resisting capacity is somewhat very high in our ductile material. Okay, so how to find out this maximum stress? See here. So in our biaxial plane, we have a sigma 1 value and a sigma 2 value. Okay, in triaxial plane, what is stresses? Sigma 1, sigma 2 and sigma 3. Clear? If you are going to find out the maximum shear stress, that is equal to tau maximum is equal to maximum shear stress is equal to sigma 1 minus sigma 2 by 2 in x-axis. In x-axis. Clear? In x-axis. If it is in y-axis, or sometimes we go to call it as sigma 2 minus sigma 1 by 2 also, it is applicable. Sigma 2 minus sigma 1 by 2. If it is a triaxial plane, tau maximum is equal to what that one? Sigma 1 minus sigma 2 by 2, sigma 1 minus sigma 2 by 2, or sigma 2 minus sigma 3 by 2, sigma 2 minus sigma 3 by 2, or sigma 3 minus sigma 1 by 2. If you're going to calculate the maximum shear stress in biaxial plane or triaxial plane by using these formulas. What about the tau maximum? The tau maximum is equal to sigma yt by factor of safety. Please try to understand. Already you know what is sigma 1 maximum principal stress, maximum principal strain. I will tell you how to find out the sigma 1 value and sigma 2 value in last theory of failure. Okay, so if it is biaxial plane, sigma 1 minus sigma 2 by 2, it is sigma 2 or minus sigma 1 by 2. Or in triaxial plane, sigma tau max is equal to sigma 1 minus sigma 2 by 2, or sigma 2 minus sigma 3 by 2, or sigma 3 minus sigma 1 by 2. So based on the given plane, we are going to calculate the maximum shear stress. Yes, I understand.
Yes, sir.
Yes, sir.
Yes. Okay. And one more very important point is for steel component, or we call it as for ductile material. For ductile material, one more very important formula is tau maximum is equal to sigma yt by 2 into factor of safety. ఇది ఎప్పుడు వాడాలి మనం ఫార్ములా? In given problem, they will clearly say that the yield point stress is one half of the yield stress in tension. That is nothing but shear stress. If you're going to calculate in terms of a simple tension, in the time we're going to calculate tau maximum by using this formula. That is the sigma yt by 2 into factor of safety. But this formula we're going to calculate only for biaxial system. How to calculate the maximum shear stress annappudu, if you're going to use this formula, or maximum shear stress for simple tension. టెస్ట్ అన్నప్పుడు ఏంటి, టౌ maximum is equal to sigma yt by 2 into factor of safety. These two formulas are very important. And how to get this tau maximum value? How to get this? In our given problem, they will give the only factor of safety value. They will not give sigma yt value and tau maximum value. The given material is a steel material. How to calculate? Anyone? Anyone? Calculate the maximum CS test value for a steel material, for a, or for ductile material, for ductile material. How to get, going to calculate? The factor of safety value is nearly 0.5. They will give only one value. How to calculate the maximum shear stress value? Anyone? 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 Babu, anyone? They will give only factor of safety value. They will not give any tau maximum value and sigma yt value. How we are going to calculate? Huh? First you calculate this tau maximum value. In biaxial plane, what is tau maximum value? Sigma 1 minus sigma 2 by 2. What is sigma 2? Sigma 2. Sigma 2 is equal to 0. What is sigma 1? It is a maximum principal stress. What is sigma 1? They will give the load. That is W by A. Load is W by A. We are going to get a sigma 1 value. And what is sigma yt value for ductile material? Sigma yt is equal to 0.44 into sigma yt is equal to 0.44. Sigma u is equal to 0.44 into sigma yt value. Okay, they will give sigma u value. What about sigma u value? Sigma y is equal to sigma u by 0.044. Sigma y is equal to sigma u by 0.44. They will give the sigma u value. Then simply substitute the sigma u and you can get the sigma y value, and after you substitute all the values in the given problem, then you calculate the maximum CSS value. Okay, ఫాస్ట్గా అయిపోలా, స్టెప్ బై స్టెప్ వెంటనే. ఒకటేంటి, ఒకవేళ టౌ మ్యాక్సిమం వాల్యూ ఇస్తే చేస్తాం, టౌ మ్యాక్సిమం వాల్యూ లేకపోతే ఏంటి, బయాక్సల్ ప్లేన్లో సిగ్మా 1 మైనస్ సిగ్మా 2 by 2 ఆ సిగ్మా 2 మైనస్ సిగ్మా 1 by 2 ఏదైనా ఒకటే. సిగ్మా వైటీ వాల్యూ ఇన్ టర్మ్స్ ఆఫ్ మెటీరియల్లో ఇవ్వచ్చు, లేదంటే డైరెక్ట్ వాల్యూ ఇవ్వచ్చు, ఫ్యాక్టర్ సేఫ్టీ వాల్యూ కూడా వాడే ఇవ్వచ్చు. సో మన డేటా బట్టి మనం మూవ్ అవ్వాలి. లేదు, ఇఫ్ యూర్ గోయింగ్ టు క్యాల్కులేట్ ది మాక్సిమం సిఎస్ టెస్ట్ ఫర్ సింపుల్ టెన్షన్, అప్పుడేంటి, టౌ మాక్సిమం ఇస్ ఈక్వల్ టు 2 sigma yt by 2 into factor of safety. These two variables, two formulas, they will give one problem. Clear? But in this maximum CS test theory is applicable for you consider the hexagonal plane. See here, in previous problem, rectangular components. In our maximum CS test theory will be applied for hexagonal plane. Or understand what I am saying? Or understand? Yes sir, no?
Yes, sir.
Yes.
Yes.
Third one, maximum principal strain theory. First one ఏంటి, stress theory. This one is strain theory, is also called as a Venant's theory అంటాం. ఓకేనా, ఇది కూడా సేమ్ అంతే. అండర్ ది strain which can be developed up to a maximum yield point occur, the theory we are called as a ఏమంటాం మనము, ప్రిన్సిపల్ స్ట్రైన్ థియరీ. స్ట్రెస్ అంటే ఏంటి, ద మాక్సిమం స్ట్రెస్ విల్ రీచ్ ది yield పాయింట్ ఆఫ్ ఎ గివెన్ మెంబర్ అండర్ ఏ సింపుల్ టెన్షన్ టెస్ట్. ఇక్కడ ఏంటి, ద ఫెయిల్యూర్ ఆర్ yielding అక్కర్ అండర్ ఏ maximum principal strain condition in a biaxial plane. The theory were called as a maximum principal strain theory. Yes, in this maximum principal strain theory, already I think all of you know, we are having a one matrix is there, strain matrix. Yes or no? What about the strain matrix? Sigma 1 and nu Poisson ratio into sigma 2. Yes. Next, Poisson ratio into sigma 1. Next, sigma 2, and this one is sigma 1. Yes. In our x-axis, we clearly observe the sigma 1. In y-axis, the stress which is going to multiplied by a Poisson ratio. What is Poisson ratio? It is a ratio of lateral strain to the longitudinal strain. Yes, in this system, in this theory of failures, if you're going to calculate the maximum strain, that is equal to sigma T1 by E minus sigma T2 by M into E. What is E? What is E? Young's modulus. What about sigma T1? Maximum principal stress. What is sigma T2? Minimum principal stress. What about M? 1 by M is Poisson ratio. E is Young's modulus. Clear? So if you are going to calculate the maximum strain in the maximum principal strain theory, we are going to use this formula to calculate the maximum strain. So and one more is called as the strain, that is E maximum and epsilon. E maximum strain is equal to one more very important formula is equal to sigma yt by Young's modulus into factor of safety. This maximum principal strain theory is also used for only brittle material. Remember, principal stress theory, strain theory, both are used for brittle material. Maximum stress theory used for ductile material. In this theory, will applicable for the components like ellipse. In this maximum theory, we are going to use a parallelogram method. And parallelogram. See here. This one is y-axis and this one is x-axis. Principal stress theory enti rectangular components. Maximum shear stress theory enti hexagonal planes. And maximum principal strain theory parallelogram method. But what is the formula we are going to use here? E maximum is equal to, or epsilon maximum is equal to sigma T1 by E minus sigma T2 by M into E. It's a very important formula. Okay, na? Or sometimes we can call it as E maximum is equal to, well, if it is a triaxial plane, sigma maximum is equal to sigma T1 minus sigma T2 వస్తుంది. దాంతో పాటు sigma T2 minus sigma T2 by E minus sigma 3 by M into E. In our biaxial plane, what happened? The sigma T2 value 0. In triaxial plane, sigma T3 value 0. Yes or no? I understand. Babu.
Yes, sir.
Yes.
Sir.
So, చెప్పండి ప్లీజ్ బాబు చెప్పండి. ఎవరు సార్ అన్నారు. Please ask the doubt. Okay, right. So in E maximum, that is E maximum strain is equal to sigma T1 by E minus sigma T2 by M into E. What is sigma T1? Maximum principal stress, minimum principal stress. What about E? Young's modulus minus 1 by M is Poisson ratio value into E value. ఇది ఎప్పుడు biaxial plane లో. If it is triaxial plane, ఇది వస్తుంది. Along with this one more formula is sigma T2 by E minus sigma T3 by M into E. But in biaxial plane ఏంటి? Sigma T2 is equal to 0. అంటే మొత్తం 0 అయిపోతుంది. In triaxial plane, sigma T3 value is 0. What about the E maximum value? E maximum is equal to, again we are going to write sigma yt by E into factor of safety. This formula we are going to use. Simple. But this theory also applicable for to get a brittle materials. Simple theory. Okay na? So the three theorems are called, first one is maximum principal stress theory, second maximum shear stress theory, third one maximum principal strain theory. The maximum principal stress theory is also called as Rankine's theory. The maximum shear stress theory is also called as Guess theory. The maximum principal strain theory is also called as a Venant's theory. Okay, maximum principal stress theory, strain theory applicable for brittle material. Maximum shear stress theory is applicable for ductile material. And maximum principal stress theory, we are going to use a rectangular components. Maximum shear stress theory is used for hexagonal components. maximum principal strain theory is applicable for parallelogram components or parallelogram structures. Clear? Are you having any doubt in these three concepts? Just ask. I will give 2 minutes time. If you're having any doubt in these three failures, just ask me. Make it fast. Please.
What
I
else?
wonder. Yes, good, good, good. Okay, next. Fourth theory. Total strain energy theory. What is strain energy? Anyone? What is strain energy? Anyone? Anybody? What is strain energy? What is strain energy? What is strain energy? Please. What is strain energy? చెప్పగలరా? Strain energy means before failure occur. Before failure occur, what is the amount of energy will be observing takes place? That energy were called as a strain energy. According to stress strain diagram, where the energy is going to observe, in a ultimate point or yield point? Give me the answer. In which point we are going to observe the energy, whether it is ultimate stress point or yield point? Please.
Yield
If
point, sir.
yes, good. So why? Because of the failure will occur only yield point. Before failure or before start the failure, it has to observing some energy. That is, according to this maximum strain energy theory, the failure of your body will occur in a yield point stress. What is the amount of energy will be stored per unit volume? That theory we are called as a maximum or total strain energy. This theory is mainly used for ductile material. Why? Because of in ductile material only will give the signal before breaking the component. If you're going to give the signal means what? What? It will be observing some amount of energy. Ledu, if you're going to drop the cup, it will give any signal? No signal. It is immediately going to failure. If it is immediately going to failure, what happened? It will not in a position to observing energy. So we are not supposed to consider the brittle material will have a strain energy. We are considered only for ductile material. Why? Because of it is clearly observing a amount of energy while breaking the specimen. That's why this theorem will can be applied for ductile material. Okay, now in this what call it as in this strain energy, we are going to use this equation. See here, the sigma T1 square plus sigma T2 square, that is maximum principal stress, minimum principal stress, minus 2 into sigma T1 into sigma T2 by m into E is equal to sigma Yt by factor of safety. Sigma Yt by factor of safety. Sigma Yt by factor of safety. This is a basic equation we are going to use in our maximum strain energy theorem. Okay, right. In this maximum strain energy theory, we can apply it for ellipse components. See here, it is ellipse. See, each and every theorem will explained will applicable for type of material. In our gate examination, sometimes they will ask match the following. First one. So this is a, okay, and it's a B column. In A column, they will call it as Rankine's theory. Rankine theory. Okay, and next second one, maximum principal strain theory, and third one, maximum shear stress theory. In fourth one, total strain energy theory. In B column, they will give the like this. They will give the parallelogram. They will give the parallelogram. And second one, they will give the rectangular components. In third column, they will give the hexagon. Okay, na? Hexagon like this, hexagon. And fourth one, they will give the ellipse. Just to match the following. What about Rankine theory? What about Rankine theory? Rankine theory is applicable for Babu. Rankine theory is applicable for rectangular components. What is maximum principal strain theory? Hexagonal. Maximum shear stress theory? Parallelogram. And total strain theory? Ellipse. So like that, they will ask one question for your gate examination. Okay, right, good. So this equation we are going to use to calculate the diameter value or sigma t1 or sigma t2 values. Okay, good. Next, last theorem is sigma, what you call it as maximum distortion. What is distortion? What is distortion? What is distortion? What is distortion? Anyone? Distortion means shear. Okay, na? So this theorem is also called as a shear strain theory. What means after observing the energy, what happened? The given specimen will failure takes place. Whenever the specimen is going to failure takes place, what happened? The theorem, the energy were called as a shear strain energy, or also called as a maximum distortion energy theory. Is also called as Henke and Van Mises theory. Henke and Van Mises theory. This theorem is also used for ductile material. Ductile material. What the theorem says, according to this theorem, the amount of energy will be absorbed biaxial plane. Biaxial plane. The theorem were called as maximum distortion energy theory. Okay, na? In this maximum distortion energy theory, we are going to use for one ductile material. The basic equation is sigma T1 square plus sigma T2 square minus 2 sigma T1 T2 is equal to sigma Y by factor of safety. What is the previous equation? See here. What is the previous equation? Same. 2 into sigma T1 into sigma T2 by M into E. But in this equation, we should remove the M into E. Just you write the sigma T1 square plus sigma T2 square minus 2 into sigma T1 into sigma T2, that is equal to sigma YT by factor of safety. It is a basic equation we are going to use. Okay, now in this maximum distortion energy theory, which can be applied, which can be applied, uh, which can be applied for ellipse also. Both ellipse also we are going to use. Okay, but I think you may have one doubt, sir. You keep on telling me sigma T1 and sigma T2, sigma T1 and sigma T2. How we are going to calculate the sigma T1 and sigma T2? By using theories of failures, what are the factors if you're going to calculate? Okay, sigma T1 ఏమన్నాము maximum principal stress theory. What about sigma T2 maximum principal, sorry, minimum principal stress theory? See here, if you're going to calculate the sigma T1 value, you have to use this equation. Clear? Sigma T1 is equal to sigma 1, or we can call it as sigma x plus sigma y by 2 plus 1 by 2 into sigma x minus sigma y square, sigma x minus sigma y square plus 4 tau square. Tau means shear stress value. This sigma x value and sigma y value they will give. In our problem, they will give. For example, sigma x is equal to 240 megapascal, sigma y is equal to 480 megapascal. Tau value is 380 megapascal. Tau value is 380. Just to calculate the sigma T1 value. If it is a positive sign, it is maximum. If it is a negative sign, here negative. If it is negative sign, it is called as a minimum principal stress. But in a biaxial plane, sigma T2 value is 0. How to get sigma T1 value? Sigma 1 plus sigma 2 by 2 plus, or sigma x plus sigma y by 2 plus 1 by 2 root of sigma x minus sigma y square plus 4 tau square. ఓకే. సో అకార్డింగ్ టు మాక్సిమం ప్రిన్సిపల్ స్ట్రెస్ థియరీ ఏముంది మనకు? చెప్పండి ఏముంది? సిగ్మా T1 ఈజ్ ఈక్వల్ టు ఏమన్నాం? ఫర్ బ్రిటల్ మెటీరియల్ ఏమన్నాము? సిగ్మా యు బై ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ అన్నాం. అవునా కదా? అవునా కదా? ది సిగ్మా T1 వాల్యూ వీఆర్ గోయింగ్ టు క్యాలిక్యులేట్ బై యూజింగ్ దిస్ ఈక్వేషన్. అందుకే చెప్పా, అది లాస్ట్లో చెప్తాను అనేసి. క్లియర్? సిగ్మా యు వాడు ఇస్తాడు, సిగ్మా T1 వీఆర్ గోయింగ్ టు యూజ్ దిస్ వన్, ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ వాడు ఇస్తాడు. ఓకే, సిగ్మా T1 అంటే ఏంటి? యూ హ్యావ్ టు యూజ్ దిస్ ఈక్వేషన్ టు క్యాలిక్యులేట్. వాట్ అబౌట్ మాక్సిమం ప్రిన్సిపల్ స్ట్రెస్ థియరీ? టౌ మాక్సిమం ఇజ్ ఈక్వల్ టు ఏమన్నాం? సిగ్మా T1 మైనస్ సిగ్మా T2 by 2. Yes or no? Sigma T1 minus sigma T2 by 2. What is sigma T2? 0. How to get sigma T1 value? This equation you are going to calculate. What about maximum principal strain theory? E maximum is equal to ఏమన్నాం? E maximum is equal to ఏమన్నాం? సార్ బ్యాక్ వెళ్ళండి. What is maximum principal strain theory? See, sigma T1 by E minus sigma T2 by M into E. How to calculate sigma T1? See, E maximum is equal to ఏమన్నాము? Sigma T1 by Young's modulus. Sigma T1 by Young's modulus minus sigma T2 by M into E. Sigma T2 by M into E. What about sigma T2? 0. It is completely 0. What about Young's modulus? What is third? How to get sigma T1? This equation you are going to calculate. Clear? Babu, are you understand?
Yes, sir.
Yes. What about fourth theorem? Maximum strain energy theory. Kada? What is the equation here? See, sigma T1 square, sigma T2 value 0. Okay, minus 2 into sigma T1. Sigma T2 means entire it is 0. Sigma y by factor of safety. Okay, always in biaxial plane, you simply put it sigma T2 is equal to 0. That's it. How to get sigma T1? Again, the formula is sigma x plus sigma y by 2 plus 1 by 2 into root of sigma x minus sigma y by whole square plus 4 tau square. Okay, what is the last theorem? What is the last theorem? Maximum distortion theory. Sigma T1 square plus sigma T2 square minus 2 into sigma T1 into sigma T2. Sigma T2 0. Okay, sigma T2 also 0. Simply you are going to get calculate sigma T1 square is equal to sigma y to a factor of safety. So based on this nomenclature, we are going to calculate any problem in our gate examination. If you keep the 5 formulas in our mind and basic concepts, it is very easy to get 2 marks in our gate examination. ఒకటి ఇస్తాడు, ఒకటి ఇవ్వడు. So you have to calculate the another variable. Okay na? Or understand how to solve the problems in our gate examination in this theory of
Yes,
failure?
sir.
Yes. Are you having any doubt? So all of you just remember each and every theorem, what is another name, and each and every theory of failure applicable for which type of material. First one enti rectangular, second one maximum shear stress enti hexagon, what is the maximum principal strain? Parallelogram. What is the maximum distortion? Ellipse. What is the maximum strain energy? Also ellipse. First one is brittle material, second one ductile material, third one brittle material, remaining 2 are ductile material. So you just remember materials and another name, what type of profiles and formulas, and one more thing is called as what is the how to calculate this tau maximum. So tau maximum is equal to sigma T1 minus sigma T2 by 2. But what is the another formula? Tau maximum is equal to sigma yt by 2 into factor of safety. This is also very important. Sigma yt by 2 into factor of safety. Sometimes they will ask to calculate the factor of safety value. Appudu em cheyala? These two are going to equate. Sigma T1 minus sigma T2 by 2 is equal to sigma yt by 2 into factor of safety. Sigma yt value vaadu istadu, sigma T2 value 0, sigma T1 value మనం చేస్తాం. ఇంకేం వస్తుంది దీని నుంచి? Factor of safety value వస్తుంది. అంటే by using a series of values in order to calculate the factor of safety, diameter, stress value or load value. ఎలా వస్తుంది stress value? Here sigma x plus sigma y by 2. What about sigma x? Load by area. Clear? సిగ్మా ఎక్స్ ఈక్వల్ లోడ్ బై ఏరియా. ఇఫ్ దే విల్ నాట్ గివ్ లోడ్ వాల్యూ, మనం ఏం చేద్దాం, అలాగే పెట్టేసుకునేస్తాం లాస్ట్ దాకా. సో అన్ని ఇస్తాడు, ఒకటి ఇవ్వడు, దాన్ని కనుక్కోవాలి. సో ఇక్కడ ఏంటంటే థియరీస్ ఆఫ్ ఫెయిల్యూర్ లాజిక్ ఏంటంటే ఇచ్చిన వేరియబుల్ ఏంటి, అన్నోన్ వేరియబుల్ ఏం కనుక్కోవాలా, ఈ రెండు మనకి కరెక్ట్గా లాజిక్ తెలిస్తే డెఫినెట్లీ we're going to get 2 marks. Each and every year gate examination, they will definitely ask one problem on your theories of failures. Clear? Theories of failures. Just like the problems are like this. ఇలా ఉండే problems. So just the load on a bolt consists of an axial load ఇచ్చాడు. They will give the shear force ఇచ్చాడు. Shear force నుంచి we're going to calculate the shear stress. Okay na? Calculate the diameter of the bolt according to maximum principal stress theory, మ్యాక్సిమం సిఎస్ స్ట్రెస్ థియరీ, స్ట్రైన్ థియరీ, 5 థియరమ్స్ అనమాట. ఎలా చూడండి, ఫస్ట్ వాట్ ఆర్ ద డేటా చూడండి. ఫస్ట్ ఏంటి, ఫస్ట్ క్యాల్కులేట్ ది సిగ్మా 1 అంటే సిగ్మా ఎక్స్ వాల్యూ. వాట్ అబౌట్ సిగ్మా వై వాల్యూ ఇవ్వలేదు కాబట్టి 0. ఓకే, దీన్ని క్యాల్కులేట్ ది టౌ వాల్యూ. ఎందుకు, మనకు తీసుకున్న ఫార్ములా ఏమున్నాయి మనకు, సిగ్మా ఎక్స్ ప్లస్ సిగ్మా వై బై 2 అంటే ఏంటి, సిగ్మా వై లేదు కాబట్టి సింపుల్ 0. సిగ్మా ఎక్స్ అంటే ఏంటి, లోడ్ బై ఏరియా చేసాం. సిగ్మా 2 వాల్యూ 0. ఓకే, సో నెక్స్ట్ మనకి ఇంకా టౌ వాల్యూ కావాలా. ఎలా వస్తుంది టౌ వాల్యూ, షియర్ లోడ్ బై ఏరియా. సిగ్మా 2 ఆల్సో 0. ఇన్ దిస్ కేస్ సిగ్మా T1 చేసాం. ఓకే, నెక్స్ట్ సిగ్మా T1 వచ్చాక చేసాము అకార్డింగ్ టు మాక్సిమం ప్రిన్సిపల్ స్ట్రెస్ థియరీ. ఏంటి, సిగ్మా T1 ఈజ్ ఈక్వల్ టు సిగ్మా యూ బై ఫ్యాక్టర్ ఆఫ్ సేఫ్టీ. అయిపోయింది. వాట్ ఈస్ మాక్సిమం సిఎస్ స్ట్రెస్ థియరీ, టౌ మాక్సిమం ఈజ్ ఈక్వల్ టు ఏంటి, సిగ్మా 1 మైనస్ సిగ్మా 2 బై 2 సి. అంతే. వాట్ ఈస్ మాక్సిమం, ఇలాగా. సో జస్ట్ యూ క్యాలిక్యులేట్ ఆల్ ద థియరమ్స్. వాట్ ఇస్ ద డయామీటర్ అంటే అకార్డింగ్ టు ప్రిన్సిపల్ స్ట్రెస్ థియరీ వాట్ ఇస్ ద డయామీటర్, అకార్డింగ్ టు సిఎస్ స్ట్రెస్ థియరీ వాట్ ఇస్ ద డయామీటర్, ఇలా కనుక్కుంటూ రావాలా. ఎందుకు, బేస్డ్ ఆన్ ద థియరమ్ బట్టి యూ కెన్ చేంజ్ ద డయామీటర్ ఆఫ్ ది bolt. If it is according to maximum principal strain theory, what is the diameter value, 12.7. Next ఏంటి, according to strain theory diameter is 12.78. It is going to changes. Why? Because of if it is applicable for ductile material or brittle material, based on the theorem the diameter of the value is going to change. క్లియర్. ఇలాగ మీరు ప్రాక్టీస్ అంటే ఇంత లెంతీ ప్రాబ్లమ్స్ ఇవ్వడు, షార్ట్ కట్ లో ఇస్తాడు. దాన్ని మనం ఏం చేయాలంటే విత్ ఇన్ ద టైమ్ వీఆర్ గోయింగ్ టు ట్రై టు సాల్వ్ ద ప్రాబ్లమ్. ఓకే రైట్. ఎనీ డౌట్స్ యూ కెన్ ఆస్క్.
నో సార్.
నో. ఓకే, సో మీరు చూడండి, try to solve number of problems on your previous question papers. If you're having any doubt, you can please come to contact or you can make a phone call. I will clarify your doubt. Yes.
ఓకే సార్.
So I think are you understand something?
ఎస్ సార్.
కొద్దిగా అర్థమైందా బాబు? 315.
ఎస్ సార్.
ఓకే, what about 390? At least you understand what is what. అసలు థియరీస్ ఆఫ్ ఫెయిల్యూర్స్ అంటే ఏంటి అర్థమైందా పోనీ? వాట్ ఇస్ ద కాన్సెప్ట్ అండ్ వాట్ ఆర్ టైప్స్ ఆఫ్ థియరీస్ ఆఫ్ ఫెయిల్యూర్స్, హౌ వీఆర్ గోయింగ్ టు ట్రై టు సాల్వ్. అంటే నేను చెప్పినంత మాత్రం మీకు రాదు, మీరు ఒకసారి ప్రాక్టీస్ చేస్తే ఇట్ ఇస్ సమ్వాట్ వెరీ ఈజీ టు క్యాలిక్యులేట్ ది ప్రాబ్లమ్స్. ఓకే, దట్ ఇస్ మై ఇంటెన్షన్ వై ఐఎమ్ గోయింగ్ టు ప్రిపేర్ దిస్ నెంబర్ ఆఫ్ స్లైడ్స్ అండ్ ఐ విల్ ట్రై టు ఎక్స్ప్లెయిన్.
షేర్ చేస్తారా సార్?
ఖచ్చితంగా షూర్ ఇస్తాను.
థ్యాంక్ యూ సార్.
All right, thank you ma, thank you so much for attending the class. So for next class I'm going to come with one more topic. I hope all of you understand my concepts. In previous first gate class also I will explain that what called as power transient devices. In second class I'm going to explain theories of failures. I think in third class I am trying to explain the design of flywheel and dynamometers. Okay, just you keep on watching, keep on attend the class and hope to get some knowledge. Okay, thank you so much. Okay, thank you.